how the testing started and where we are today, and also talk in detail about packaging testing standards and how we can use them in our software. In the second part of the webinar, we'll also showcase a typical equipment configuration role can offer and show you the test profiles you can use for your own projects. So I believe we can begin the event. So just a few words about our company for the first timers who are present here. Roll Technologies is a manufacturer of equipment for vibration testing, calibration, and data acquisition stationed in Riga, Latvia. We offer customized solutions for customers in automotive, aerospace, research, energy, and other industries. Our key value is to provide tailor-made solutions to our customers and solve any problems they approach us with. With Rula, your company will save the budget both short-term and long-term, as we provide all our software updates for free and offer lifetime compatibility across all versions of Windows, so you'll never have to pay twice for the same system. So with more people joining, let's start. Let me introduce our speaker today. With me here is Philips Tumšais. Philips, the floor is yours.
Hello, everyone. In this webinar, we're going to talk about vibration testing in packaging. We will discuss standards, technical specifications, types of setups, and most common test types. We're hoping to make it interesting and worthwhile. Today, we will discuss why we need package testing. We will cover history of package testing. We will discuss the standards, equipment. I'll show you some test examples and we will make conclusions. First of all, let's talk about why do we need vibration tests in packaging. Nowadays, there are a lot of shipping companies whose aim is to transport the package safely. And to test the durability and the protection level, these companies use vibration tests. Vibration tests can be applied to the range from small package boxes or huge shipping containers. All of these ways of transporting must be tested. Package vibration tests develops protocols and design standards that define how packages should perform to ensure the protection of their contents during the ever-changing risks of the global distribution environment. And you can apply packaging tests in different spheres. For example, it can be safety tests, durability analysis. You can perform road shaking tests, drop tests. You can use vibration tests for structural design and its improvement, and of course, shock testing. The history of package testing began in 1960s when engineers started to use mechanically driven eccentric cam vibration machines, which can be named like first drop machines. But the vibration was a repetitive shock rather than usual vibration, which we all know. Then in 1970s, assign tests appeared, and in that case, people started to search residences and develop residence search and dwell. Now the sign test is usually used for package design, structural improvement, resonance search, and so on. In 80s, when a random test was developed, engineers had an ability to make a correlation between real life and lab tests. For example, using random tests, you can replicate real life events like rail crossing, truck shipment, turbulence, or plane bad landing. And then in 80s appeared first standards. I think you're familiar with ISTA and MIL-STD, and these standards covered some packaging. And now, from the 2000, engineers started to use the recorded data to replicate real-life events. For example, you can record road shaking and replicate it using vibration system and the shaker. Now let's talk a little bit about the standards. I'll cover the most famous ones. The first one is ISTA. ISTA is famous standards for packaging. It can cover non-simulation tests, partial simulation tests, general simulation tests. It can be used during the development phase. And ISTA has different parts. For example, we have ISTA 6 Amazon. It's Amazon standards for the packages. And there is Amazon Packaging Support and Supply Network, which can certify labs and provide package certification. Also, I think you know ASTM, it's Free International Standards, and I think you know that ASTM covers all spheres of engineering, and in packaging, I think you know ASTM D4169 track profile. It's a really famous random profile. And of course, I need to mention MIL STD. It's well-known military standards for design and testing an object for military purposes. And now let's talk about the package tests. We can divide them into two categories, like drop tests. Here on the first picture, we can see a drop machine, and vibration tests using regular controller, vibration shakers, and so on. In Ruler, we provide solutions for these two categories. Drop tests are used for performing a real-life shock impact by dropping an object. For this type of test, you need a drop machine like shown here, a controller. Here you see our RLC21 controller, and the transient capture option. For regular vibration tests, you need also controllers. Here you see RLC25. You need an amplifier and a regular shaker. This way you can replicate road shaking, shocks, recorded data, for example, plane landing, and even test your objects for their durability. Most common test types are sine, shock, random, FDR, and transient capture. Also, if you need to record the data during the real shipment process, I can advise you to use our RLR17 portable data recorder. It can be placed inside of the shipment container or box, and using this device, you can autonomously record all the data during the shipment process. After that, you can analyze the results and check the structural safety. And now let's talk about our first setup. I'll show you a transient capture test. Here, I'll turn on. I think you can see my setup. Here we have one PC connected to our RLC21 controller. It is connected with an amplifier and the shaker. Here on the Tira TV51110 shaker, you can see our testing object. It has accelerometer placed on it, and we have an accelerometer inside our metal frame. The accelerometer on the metal frame is connected with the first controller, and
one sec, we can't see the webcam, I think.
Let's check it. Can you see it now?
Yeah, you can.
Okay.
Thank you.
And using the second controller, we will run a transient capture test and collect the data. Using the first system, we will influence our object using MIL-STD-810H half-sine shock. Here on the slide, you can see the profile. And now let's go to our software here, and let's create a transient capture test. We select transient capture. We will press create test. Here we need trigger and filtration tab. We will set level at 1.3 G. We will set time before shock as 100 milliseconds. After that, we need to set the filtering options. And before we do it, let's enter shock frequency measuring period. It will be 10 seconds. Here, let's set these values. And after that, let's set our channels. I have a special configuration. It is called packaging transient capture. And now I'll disable the second, the third, and the fourth channel, and let's apply the settings. Now I'll check the amplifier. I set the level at 25%, and now I'll start transient capture test. And after the startup, I'll start the shock test on other PC. Here you see that the transient process is going, and when it finishes, we will be ready to detect the shocks. Oh, I'm sorry, I forgot about one feature. I'll stop the test now, go to test settings. And because I have a sensor which is placed on the metal frame, it is placed upside down, I have to invert this channel. And now let's start it again. Wait for some time. And now let's start the shock test. Here you see we detected our shocks, and in this profile we have the maximum acceleration of 2G, but because of the sensor placed on our testing object, we get a little bit more. Here we have 2.5 G, and that's the way you can get the data from shock machines and so on. Here on the left side, you can change the settings during the test and apply them. You can do it right in the runtime. And here we see that we received all our 40 shocks from the test. And here you can see that we get our last shock. Let's stop the test. And here you can select different shocks, see the amplitude, duration, and get all the data you need. Now let's go back to our presentation. And now we're going to talk about single shaker setup. I'll connect the amplifier back to the main controller, and we will talk about the next test, MIL-STD 810G terminal peak. It's a widely used shock test in MIL-STD, and it's really famous. I hope you know it. And now let me change the settings, and we will create this test profile using our software.
Yeah, meanwhile, we had one question in chat. Can we capture the shocks on multiple channels at the same time? The short answer is yes, we can.
So you see that I connected the amplifier to the main controller, and on the first channel we have our accelerometer, which is placed on the metal frame, and on the second we have our accelerometer on the top of our testing box. Now let's go back to the software, and here we have an option, create test from the template. And here we select terminal peak, and the test profile will be created automatically. Here we go to limits. We need to select our shaker. And then let's select our packaging tests setup in channels. Here you see on the first channel we have 10 millivolts per G IP sensor, and on the second we have 100 millivolts per G IP sensor. We will disable the third and the fourth channel. Let me double check the settings. And let's perform 20 shocks. Let's apply the settings, press OK. I'll check the amplifier. So the level is set, and now we can run this test. Here you see that we are running this test. Let's create spectrum. Here you can see a spectrum of this test. And here we see our results. In that case, you can perform some shock tests for your packaging equipment or packages themselves. And the next test type I want to discuss is random test. We will discuss ISTA General Simulation Test Project 3E. Here you see its profile. It's a random test. We will run it from 1 Hertz to 200 Hertz frequency. And you also can create this test using templates. Here you see ISTA, random, simulation test project 3E. Here you see the profile. In the limits, we need to set the shaker. We won't run this test for 30 minutes, so let's set it to 45 seconds. And this test cannot be run at 100% level on our shaker, so I'll decrease it to 30%. And in channels, we select our configuration and disable the third and the fourth channel. Everything is okay. And now let's run this test. This test is used for unitized loads of similar retail or institutional packaged products shipped through a full truckload delivery system where an entire trailer load is filled with the packaged products. It's often used for one destination, such as from a manufacturing location to a distribution center. And here you see that we're starting up. Maybe you can even hear our test. It sounds like a real road shaking. And I need to mention that here we'll wait some time. Here you see the spectrum is really close to the profile. And now I need to mention that we have all our famous random profiles, like, as I mentioned, ASTM D4169 truck profiles, air levels, rail levels, and so on. Do we have any questions?
Oh yeah, actually we do. So one question about the random test. Can we set kurtosis values in it?
Yes, we have such option in our settings. It is placed in Control tab. Here you see a checkbox here, and pressing this button, you can set the settings of this option.
Okay, great.
And now let's go to our final test. We will discuss FDR. And for this field data replication, we recorded a road shaking in Riga using Avrila 19 data recorder. It was placed in the car, and we placed some sensors and recorded the data. I have a small video about it. I think here you see that the car moved across the city and we recorded data. After that, I a little bit filtered it to reduce some noises and make it available to run on our shaker. And this data recording proves that roads in Riga are not really good. And I think now we are ready to see the recorded data. Here you see its accelerogram here. And now let's go back here. We select field data replication. Here we can add our file. You see it. After that, we'll set the schedule. We will run it on 50% level, and we will run it for 45 seconds. After that, we need to check all other settings. Here we see that we have our shaker and set our channels. Disable the third and fourth, and let's apply the settings. And now let's run our test. It will take some time to start up, and using our field data replication option, you can record real life events and after that replicate them using your vibration control system. I think you can hear it. We got some vibrations. And here you see that, and here that the car is increasing its speed.
Yeah, Martin commented, nice view of Riga. We did our best. Now you can also hear Riga.
And I need to mention that using our data analyzing software, you can filter the signals before applying them to the shaker and filter them, cut them, and all other features. It's really useful, and I think soon we will get a new release, and maybe we will make a webinar about some file magic with the data recordings.
So one more question. So for FDR tests, which formats can be used? So which formats can you convert to the accelerogram?
For example, if you don't have our file extension, which is called WebFX, you can import data from text files like TXT, CSV, like sound files. For example, you have an audio which you want to replicate, and I think we covered all base formats of the data and recorded data, of course. And I think that's all tests I wanted to show you today. And in the end of the webinar, I want to say that package testing is used for safety tests, durability, shock tests, and drop tests. You saw that you can analyze the shock, create some shock impacts, replicate road shaking, replicate real life events, and all this vibration testing improved packaging sphere a lot. In Ruler, we have all types of devices and software for packaging tests, and I think we covered all most famous standards and described examples of vibration tests.
All right, so we have some more questions, I think. So the first one is, can we control a shock test with multiple channels?
Yes, we have this option. I'll show you in the software. Let's go back to the shock. This option is used when we have large objects and long objects which don't have a place for a sensor in its middle. So here, test settings, we go to channels, select the second one as control, and yes, you can use this option. Also, you can set the influence coefficient, which will be used during the control phase of the test. And this feature is really useful now.
Yeah, I also need to mention that we have shock and FDR as a multi-shaker variant. So you can use multiple shakers just to test long objects or very large objects and save a lot of time. And the last question, I believe, can you add more test templates if I send you a specification?
Yes, of course, we will add them, send, and we will enter them in our software. And in the next release, you'll get your profiles.
All right. Okay, Phillips, thank you for the insightful event. We will follow up with a short email in about 2 days, maybe on Monday. So if you have any other questions regarding the system or the tests you should use, feel free to message us, drop us an email, or contact us on LinkedIn. And enjoy the rest of your day. Thank you, everybody, for participating, and see you next time.
Bye.